Okay, cool. I think we'll go ahead and get started. Hi, everybody. My name is Grace Rosado. I am a lead programmer with Austin Design Week, and I'm very excited to have all of you guys join. It's our first day. This is one of my first events that I'm hosting this week, which is very exciting, and it's a great one. So I'm happy that all of you guys have joined us, whether you're returning or if you're new. We have a ton of, let's see. Oh, yeah, I'll go ahead and enable transcribing. There you guys go. We have a ton of events this week. There's so much going on. And what's cool about Austin Design Week, especially the last couple of years, is every single event has a protected time slot. So you guys will be able to see pretty much everything if you want to and your schedule allows, especially virtual events. These are our social media channels right here. If you guys want to follow us or tag us in what you're doing, it's a great place to connect with other attendees and even hosts and the Design Week staff. We have one of our great volunteers in the chat today that just posted a message of kind of do's and don'ts of how virtual events work. And if you guys have any questions, the chat's a great place to put those there. If you want to go to the next one. Oh yeah, that's the short link. It's basically go to austindesignweek.com. That's where you'll find stuff. And on the next slide, it's just a quick thank you to our sponsors. Austin Design Week is a nonprofit volunteer led event, and we're very excited. We've been growing every single year, and last year obviously was our first virtual festival, and it's fun being able to mix virtual with in-person events for everybody who isn't local and based in Austin. But that's pretty much it for me. We'll just go ahead and I'll kick it off to Lee Nguyen, and they'll go ahead and take it over. And if you guys have any questions, just put them in the chat and I'll be here for anything you guys need. Thank you so much.
Thanks so much, Grayson. So I'm Lee Nguyen. I'm going to be talking about discovering physical digital spaces. In this talk, you're going to learn what a physical digital space is. You're going to learn the assumptions that go into flat screen design and why they no longer work for spatial technologies. And you're going to learn how to evolve your processes and your tools to design for physical digital spaces. That's a lot to cover, so I'm not going to have, oops, sorry, a little bit delayed on our slides here. There we go. So it's a lot to cover, so I'm not going to have time for questions, but you can put those in the chat and I'll post answers on my website at this URL in a few days. All right, so housekeeping done. First, I want to provide some context and go all the way back to the beginning. Once upon a time, we all used analog tools. It didn't matter what industry you were in, you got your work done using paper and pencil and the specialized tools of your trade. That started to change in 1944 with the invention of the first programmable digital computer. Now, instead of doing calculations involving large numbers by hand, you could do them on the computer, provided that you were the US Navy and you had a room the size of a movie theater to work in. Over the ensuing years, though, computers started to take on more and more tasks that were formerly done on paper. As they became smaller and more affordable and more flexible, they progressed from being used solely by academics in the military to commercial applications, such as production scheduling and airline reservations. They also began to take over different types of paper-based work. While the original computers were invented to do hard math problems, by the 1960s, they were starting to be used to display information on screens. This meant that they could eventually take over tasks like typing manuscripts. In 1973, the Xerox Alto introduced the first graphical user interface, and this paved the way for computers to take on a lot of new work, such as internal business communication via email and chat, drafting, typesetting and design, technical diagramming, as well as programming. All of these applications were part of the Xerox Alto, and all of these tasks were originally done on paper. If there was any doubt, it's reinforced by the fact that the Alto's screen was 8.5 by 11 inches, the size of a standard piece of letter paper. So now, instead of typing or drawing, instead of physically cutting and pasting shapes on a drafting board, instead of recording and referencing information in ledgers and books, you could do it on the computer instead. This meant that people whose jobs relied primarily on paper-based activities became the new target market for information technology. But information technology was limited. It was limited to information that could be effectively conveyed on two-dimensional screens. And it was also limited to people with stationary workflows. Personal computers started out as big, bulky things. They required desks, which meant offices. In the ensuing decades, they've gotten smaller and lighter, but the stationary nature of this kind of work has not materially changed, which is why we all need standing desks and Fitbits that remind us to blink every once in a while. What this means is that for the past 40 years, there's been a barrier between the so-called knowledge workers served by information technology and everyone else. Now, remember when we started, we were all in the same boat. Everyone in every industry used analog tools. The rise of information technology disproportionately impacted knowledge workers, while leaving other types of work relatively untouched. So if you don't work at a desk, if you're an electrician, if you're a farmer, if you're a physical therapist, computers are of limited use to you unless you're using them for paperwork. But here's the thing, knowledge workers represent only about 40% of the US workforce. This means that the tech industry has been ignoring 60% of potential customers for 40 years. That's a huge oversight. So that's tech as a whole, but it's important to note that this is also the context that user-centered design was born into. The first documented use of the term user-centered design was in 1977 in this article, which explicitly advocates for the needs of managerial, engineering, industrial, and scientific users. The Xerox Alto, which remember was that groundbreaking first GUI system, was primarily designed based on the needs of Xerox PARC's own engineers. That work inspired the Apple Macintosh, as well as one of the first books on human-computer interaction in 1983, which was itself structured around screen-based tasks like text editing. In terms of user research, some of the earliest usability tests were conducted by Bell Labs in the 1970s, and they look nearly identical to moderated user tests today. They were testing computer-based office systems, and just like now, they had participants completing stationary tasks with a keyboard, viewing output on a screen, and monitored by a moderator. As computers have evolved, we've lugged these legacy design practices with us, retrofitting them to work with new kinds of interfaces rather than reinventing them. We rarely acknowledge that these methods are founded on the assumptions of a flat screen world. But in the past few years, the form of computers has started to dramatically change. Chips and sensors and power sources have become compact and efficient enough to enable not just smartphones, but a large number of new devices, like the Fitbit I was just talking about. We now have smart speakers and cameras in our homes to sense and make sense of subtle changes in our environments. Virtual and augmented reality are starting to come into their own, enabling contextualized, volumetric visualizations. And the pandemic brought a huge surge of interest in robotics in the healthcare and hospitality industries as companies scrambled to find contactless service solutions and looked for ways to cut payroll costs. And these are not new changes. One of the first major mainstream IoT devices was the Roomba all the way back in 2002. In 2006, Nintendo launched the Wii with a motion control system that helped it sell more than 100 million units. The Microsoft Kinect offered more advanced motion tracking and it was hackable. It sold 1 million units within 2 weeks of its launch 4 years later in 2010. So we've been gradually trending away from screens for a while. But now with new smart devices and augmented reality, not to mention the pandemic, the pace of this change is accelerating and anyone who ignores it is at risk of being left behind. So it's no longer sufficient to only design for computers as if they were locked behind screens, because they're not. They're no longer limited to desks, and they're no longer restricted to knowledge workers. And what this means is that the barrier between knowledge workers and everyone else is about to come crashing down. And this changes the way we design technology. When you're designing for flat screens, the main thing you need to understand is the adimensional flow of information. Paper and screens are best for displaying content with 2 dimensions tops, and you can see this in our design processes. Many of our top techniques depend upon paper prototypes, 2-dimensional wireframes, and card sorting, which all work very well when you're only dealing with intangible data and concepts. But the new paradigm is one of dimensional information, one where we need to understand the physical spaces we occupy and the data that informs and describes those spaces. A paper prototype is a terrible way to convey instructions for safe operation of a forklift in a crowded warehouse, for instance. Our old paradigm was one of disembodied data. The new one has metadata intertwined with real world spaces. Before we had cyberspace, which was space as metaphor only. Now we're creating true physical digital spaces. So what is a physical digital space? There are a lot of buzzwords right now being used to talk about the integration of information technology with physical spaces. Right now, thanks to Facebook, everyone's talking about the metaverse, but before that, it was smart spaces or ambient intelligence. If they're referring more to the processing, they might talk about edge or fog computing. And if they're referring more to the interface, they might talk about immersive or spatial or ubiquitous computing. In production industries, it's usually just referred to as automation or maybe industrial IoT. You should also be aware that a lot of this discussion is happening at the level of individual devices and tools, such as computer vision and blockchain, rather than looking at the ecosystem in aggregate. Today, I'm talking about physical digital spaces because I want to avoid the baggage of all those other terms and focus only on a specific meaning. So for our purposes, I'm talking about real world physical spaces, not virtual worlds, that are integrated with digital metadata specific to those spaces and the objects within them. To illustrate, here are some examples of physical digital spaces. The first example is Chevron's digital twin oil fields. So a digital twin instance, or DTI, is a virtual representation of a physical object, usually a machine or a building. It can include a 3D model, position and historical data, as well as all relevant information about that object's current status, which is collected by various systems and sensors. So the state of the virtual object corresponds to the state of the real one. Digital twins have their origins in outer space exploration, but these days they're starting to be used more in industrial applications. So you'll see energy companies like Chevron using digital twins of high value equipment in oil fields to model and react to conditions that could impact how those machines are functioning. The second example is Disney World. You can say a lot about Disney parks, but here I want to specifically focus on the Disney Genie, which is the new replacement for the FastPass system they used to have at their parks. As a park goer, you can sign up for this service to get real-time information about wait time for rides, as well as personalized recommendations about when to hit attractions on your itinerary. The third example is in the field with technicians using the Microsoft HoloLens. So one of the use cases for the HoloLens has turned out to be remote assistance for field workers. In these scenarios, a worker can be out on location wearing a HoloLens while it beams back everything they're seeing to an expert thousands of miles away. That expert can actually make annotations that will show up on objects in the field of view of the worker. So it's a way of bringing that expertise into the workspace in a contextualized way. And the last example I want to talk about is your own front yard. I want to avoid giving the impression that physical digital spaces are only accessible to large companies. Not at all. If you have a smart home device, especially more than one, chances are you're living in a physical digital space right now. Doorbell cameras offer an easy example of this. So if you have a Ring or a Wisecam, then you know it's not just a passive recording device. It actually understands what's happening on your doorstep and can take action if it sees packages or people or pets. So now that we've talked about what physical digital spaces are, let's talk about a few examples of things that are not. Stationary virtual reality experiences are not physical digital spaces because they're not directly tied with the physical world. Same thing with virtual meetings and virtual worlds like Fortnite and Roblox and Facebook's concept for the metaverse, although those are interesting for other reasons and that could be its own talk. Second example, wearables and hearables do not in and of themselves create physical digital spaces because they're usually decontextualized. Now, if you're not familiar with these terms, a wearable is something like a smartwatch. It's a connected device that you wear and it monitors things like your heart rate. A hearable is something like your Apple AirPods, essentially smart headphones that can also do tracking and monitoring. When I say that they're decontextualized, I mean that they collect and report information about you as an individual, but they don't tend to extend that to the larger environment today. That being said, they do have the potential to integrate well with physical digital spaces, and I expect they'll do more of that as spatial evolves. The last thing I'll talk about is smart speakers like Alexa. These devices are borderline. If you're just using a smart speaker to play music and to keep track of your grocery list, then that's not a physical digital space. But if you have it set up to recognize different rooms in your home, or if you've used any of its security features, or if you've integrated it with other smart home devices like lights or cameras or drones, then that means it understands something about your environment and it would qualify. So we've talked about removing the barrier to new kinds of users, and we've talked about the rise of physical digital spaces. Let's get back to what this all means for design. And the fact is, it's going to have a huge impact. So first, the good news. User-centered design as a philosophy is uniquely well suited to helping companies navigate this dramatic shift in technology and users. After all, designing products to support these new audiences and workflows will require throwing out old assumptions and throwing ourselves into learning about new user needs and constraints. But here's the bad news. When I talk about throwing out old assumptions, that applies to user-centered design as well. Because while user-centered design as a philosophy is well suited to this changing landscape, user-centered design's current practices are firmly mired in the same flat screen world as the rest of information technology. I say this because I've been working as a researcher in spatial technology for the past 15 years, and I've seen our design practices fail when faced with the novel issues introduced by physical digital design. I've seen spatial technology startups fold because design thinking couldn't help them identify a new audience. I've watched designers burn months of time on idealistic ideation exercises that were divorced from the needs of the business. And I've watched designers get left out of executive level conversations because their processes were perceived as adding noise and not value. But I've also seen us get it right, partnering with the business to anticipate the needs of users who are very different from today's audiences. And these evolved design practices are what I now work to share with design leaders in our industry. And that's what I'm going to be talking about today. First, let's talk about what I mean by philosophy versus practice. User-centered design at its core boils down to the idea of building products and services from the user as a starting point. Functionality should be driven by what the user needs and values. Form should be driven by the limitations of their bodies, their minds, and their contexts. Don Norman articulates this further in his 7 fundamental design principles, which are discoverability, feedback, conceptual model, affordances, signifiers, mappings, and constraints. These principles are independent of screens. In fact, Norman's concept of affordances originally derives from perceptual psychology, where it's a theory for how people perceive objects in the physical world. So even if we change our users, even if we change our technology, this fundamental approach still applies. But philosophy means nothing without practice. There's a reason why in every design job interview, you get asked to talk about your design process. People like Jared Spool and Erica Hall, not to mention all the UX boot camps, have built their business models around advocating for specific design practices. And they're not the only ones. In a popular young field that has only recently gotten its own degree programs, practice is how we weed out the people who don't know what they're doing. We are incredibly invested in our practices. But in this new paradigm, these practices need to change. So let's talk about how our practices look today. I'm going to talk about an ideal process here where the design is involved end to end. But I want to acknowledge that not every organization is at this point. Let's start at the very beginning of the product lifecycle. Most products start with an informal hypothesis about an opportunity to create value for customers. If you're in a mature enough organization, design will be looped in pretty early on for product discovery. Of course, there are a number of different product discovery frameworks, and everyone has their preference, but whichever approach you take, it probably goes something like this. In the first stage, you'll begin exploring the problem space through research. When I talk about the problem space, this usually means learning about a focused set of problems for a predefined set of users. According to Nielsen Norman, the most common research approaches at this stage are fieldwork and customer interviews. But let's be real, if you're not a high-end research consultancy, if you're an in-house designer with a huge backlog and limited organizational buy-in, then you're not flying out to customers to do site visits for every project. So you probably make the most of what you can do, which is often remote interviews and secondary research. Once you've run a study or read some articles, you still need to analyze them to make sense of them for your project. This is the second stage. and you probably use some kind of framework, formal or informal, to figure out what from your mountain of data is worth paying attention to. On the formal side, there are several UX-specific frameworks such as AEIOU and Jared Spools from Putting Context into Context. And on the more informal side, maybe you're just going through your data and pulling out any statements that pertain to your research questions. But there's some system you use to figure out what goes into your final analysis and how to categorize and draw conclusions from it. Once you have these conclusions and insights, you can finally start to generate product or feature concepts for testing. This is the third stage. And a lot of times in 2D design, we can just go directly to wireframes or click through prototypes. Then once you have a set of potential solutions, you can test and refine them with users. In most organizations today, that's probably either in a lab or using remote testing tools like Maze or user testing, or even just Zoom. This is the final stage of product discovery before refining the design and handing it off for coding. So that's more or less how most mature organizations approach user-centered design for flat screens today. Maybe your process has a few more or fewer steps. Maybe your organization is a little more mature. Maybe it's less mature and you're still trying to get here. That's all fine. But if you're in UX, you're probably either going through or trying to get to some variant of what I just laid out. Everyone uses this and it works really well as long as you're designing for flat screens. Unfortunately, when it comes to new audiences and physical digital spaces, this approach has some serious flaws. In fact, applying the exact same design process I just outlined will result in novelty products with limited real-world value. Anyone remember 3D television? Think like that. So what are the issues here? Well, first, there's a missing first step. Jumping straight into exploration of the user's problem space assumes that you already understand the full capabilities of the technology you're designing for. It also assumes that you know your users well enough to predefine them. Now that we're talking about new physical digital spaces and designing for the 60% of the population we've been ignoring for 40 years, those are both pretty big assumptions. The second issue is that some of our most commonly used tools are optimized for flat screen design. We rely heavily on interviews for generative research. The frameworks we use for analysis don't help us key in on the information that matters for spatial technologies. Most of our design deliverables only display information in 2 dimensions, and we test our designs outside of their intended context of use. These tools were not designed to craft high-value experiences in 3-dimensional spaces, and trying to use them in that way limits what we can create. The good news is that this all boils down either to bad assumptions or to ill-suited tools, and those are both things we can fix. Let's talk about how. So when you're designing for flat screens and adimensional information-based workflows, there's a lot of baseline information that you can take for granted. For one thing, we've all been using screen-based interfaces for literally decades. That means that we have decades of firsthand experiences with these devices' capabilities and limitations. Advances such as the internet and smartphones have increased computers' connectivity and portability, but the fundamental mode of interaction hasn't changed since the Xerox Alto in 1973. So if you as a designer are trying to create a new desktop or mobile application, you don't need to spend a lot of time researching what those devices are capable of because you already know. But if you're designing for physical digital spaces and the devices that enable them, it's an entirely different story. You may be designing for an augmented reality headset that overlays visuals on the user's field of view. That device may accept gestural input, or maybe it uses some kind of remote control or clicker. As a designer, you need to know at bare minimum how the device maps the physical space, what it can detect, and how it displays information. Or maybe you're designing for an Internet of Things device, which means that you need to know exactly what kind of sensors you have available and what their limitations are. If your design depends on detecting human hand position within a fraction of an inch, you'd better be confident your hardware is capable of that. If you're designing for robots, it gets even more complicated because not only do you have to understand systems and sensors, you also need at least a casual understanding of the robot's mechanical capabilities. It's not like designing for screens. These are not familiar one-size-fits-all systems. If you're working with emerging technology companies that are designing these devices as they go, then even the engineers may still be figuring out what their hardware is capable of. Standards are still being set, and the variety of inputs and interfaces is exploding. And that's even before you factor in cross-device interactivity. There's a lot of evidence that augmented reality is going to be a great complement for IoT use cases. But in order to design for these types of systems, you're going to have to understand both technologies. So as designers in this new paradigm, as much as we believe in starting from the user, what that's going to have to look like in practice is preparing for user research by assessing the technology we're designing for first. There's one other big implicit assumption we tend to make in designing for flat screens, and that's that we're going to be designing primarily for knowledge workers. This goes back to what I was talking about at the beginning and the fact that for the past 40 years, the form factor of computers has limited who could use them. Our primary audiences have always been people who deal in at most two-dimensional information, not three-dimensional objects and spaces. And that means that there are a lot of things we could traditionally take for granted when designing for these people's workflows. Designer John Whipple talks about this in his 2012 essay on What Designers Know. And I'm quoting him when I say, "Strange then that we always begin our projects with a research phase, as if we know nothing, as if the problem hasn't existed in some other form, as if the client has all the time and money in the world. But what about the vast majority of our projects, or the vast majority of the problems that we solve within a project? I'll wager you or your colleagues have seen these problems before, and there's a fair chance that the solution is documented elsewhere in some form." This notion has come up again recently in an article that's been circulating about when to skip UX research. This article outlines 3 different situations where it may be okay to skip an explicit research phase. The first one is when there's an existing highly relevant knowledge bank of secondary research. The second situation is when you've already conducted extensive research yourself. And the third situation is when you're designing something that is low risk and low cost. Now, if you're designing for knowledge workers, this is all fine. I'm not contesting any of it. But if you're designing for the 60% of the population our industry has never served before, this is not your situation. There's no existing knowledge bank. There are no time-tested solutions. And anything you create is going to be expensive, if not in dollars, then in time. If you try to take the same shortcuts in spatial that you do for screens, you'll end up missing out on key information you need to design effective solutions for your audience's workflows. Either that or overlooking the right audience entirely. Either way, the result is either a failed product or extensive, costly rework. Let's talk about why that is. One major impact of only designing for knowledge workers for the past 40 years is that we in tech have some huge blind spots when it comes to potential customers. I'd like you to think back to your last design project. How did you learn who your users were? Maybe a PM told you. If so, how did they know? Typically, if you already have a product in market, it's the same audience as them or someone similar. If you're designing a new product from scratch, then the expected audience is often based on the product team's hypotheses. But how do you know that you've considered everyone? And how do you know that there aren't other groups of people who would value your product as much or even more than the audiences you already know about? When you're designing for knowledge workers, there are only so many industry sectors and roles to consider as potential users. And by now, our industry has been doing this work for long enough that all of these audiences are pretty familiar. So if you do a group brainstorm with your entire product team, there's a pretty decent chance that someone will bring up the right audience. But with spatial technology enabling us to serve vastly different audiences, that's no longer a safe assumption. Remember, knowledge workers are only 40% of your potential users. But how much do you personally know about the goals and workflows of farm and home management educators, for instance, or tool grinders, filers, and sharpeners, or clinical laboratory technicians? Chances are, even if these people could hugely benefit from your product, nobody on your product team is going to know enough about them to suggest them as an audience. This means that if you don't explicitly build in a step to check your blind spots during product discovery, you may never recognize your best potential customers. The other issue you'll encounter in designing for these new audiences is becoming aware of how many unspoken assumptions we make about what work looks like. Only designing for knowledge workers means that regardless of industry, you have a pretty good sense for basically how they work, because they probably work a lot like you. They sit at a desk, they receive work inputs via things like email or work order requests, they use computer applications to analyze information and create content, and they submit work as reports or code submissions or red lines or something else along those lines. These are those adimensional paper-based tasks that computers have been so good at taking over. So designing for these kinds of workflows requires learning about informational constructs, people's inputs and outputs, their work relationships, the applications they use, and how they model everything in their heads. But you're not asking how they use a computer in the first place. You're probably not asking about their work environment, what its lighting is, and whether there's Wi-Fi. You're not asking them to show you the physical movements they make to perform their work. There are a lot of things you don't need to ask about because they're pretty much the same for every knowledge worker, including you and your colleagues. But when you're designing for the 60% who are not knowledge workers, you can't make these same assumptions. Let me share an example. This is JC. He's a steel fabricator. JC works in a shop doing custom metal work. It's not climate controlled and it's really loud. He mostly works standing up, sometimes on a ladder, and he needs both of his hands to operate equipment like jacks and hammers and welders. Every day he's at work, he's at risk of burns, cuts, and exposure to toxic gases. So any interfaces he uses have to be operable with heavy work gloves and safety glasses. Here's another example. This is Maisie. She's a sterile processing technician at a regional hospital. Her job is to decontaminate medical instruments between procedures. She spends a lot of her time hunched over a sink and wears pretty extensive medical gear, as you can see here, including a gown and a mask. She also wears gloves, which she tapes to her sleeves because she's working with a lot of liquid disinfectants and detergents. So removing her gloves to check a phone or a computer is a really big deal. When you're designing for new audiences of people like JC and Maisie, you can't take anything for granted. You need to throw out any preconceived notions and focus on understanding what success looks like for their job and what processes and tools they use to accomplish it within their unique work environment. So let's circle back to that idea of the missing first step. We've talked about how important it is to understand the technology you're designing for. And we've talked about the need to account for unrecognized biases when it comes to that unfamiliar 60% of the population. So what I recommend, and what I actually do with my clients, is that before starting to do any actual user research, you first audit your technology, and second, check your customer blind spots. For the technology auditing piece, I tend to use a checklist. There is not time to go deeply into that today, but if you want to see what this looks like, there's an example up on my website at leewin.net/ADW2021. Now, in order to check your customer blind spots, I'll often recommend using the North American Industry Classification System manual. If you're not familiar with it, this is the standard system used by the government to classify businesses based on their work processes. It's a great way to get a high-level overview of a wide variety of different industries. You can find a link to that on my website as well. So that's a quick summary of how to approach what I'll call step 0. But if you're looking to learn more about this part of the process, I also did a more in-depth talk at Austin Startup Week, which is linked to on my website also. All right, so now that we've talked about assumptions, let's switch our focus to tools. There are a lot of people in our industry who would like you to believe that there is one way of designing and doing research. But in fact, even design ethnography was originally a reaction to our over-reliance on usability tests and the fact that they could tell you how to design, but not what to design. So when it comes to determining the tools that we'll use for spatial design, we should start by recognizing what information is most critical to truly provide value for users, including the 60% of the population we haven't designed for before. The first tool I want to talk about is using interviews for generative research. Now, interviews work for flat screen design because, like I mentioned earlier, you rarely need to know much about the spatial context of knowledge work. You can learn a lot about how these users work through simple conversation. At most, you may need to have a participant share their screen so you can watch them complete a task in an application. But that's not the case when you're designing for physical digital spaces. The physical space is central to the design, which means that you cannot skip observing the relationship between your participant and their environment. Being in that space yields invaluable clues to the information that infuses it. What you're looking for is things like paper forms or thumb drives being transported alongside real-world objects, barcodes, humans doing manual inspection and labeling tasks, humans following instructions in ways that involve physical tools in their own bodies, wayfinding markers, traffic cones, printed instructions taped to machinery, multi-user data entry terminals, caution barriers and safety tape, human trainers and supervisors, call and response verification tasks, blueprints, volumetric models or prototypes, emailing photographs back and forth, and any other multitude of ways that information permeates physical workflows. These are things you simply cannot get from phone or video-based interviews alone. Now, I know what you're thinking. We would all love to do more field work. The problem is always time and budget. I get it. I have been there many times. The problem is that our businesses may not yet recognize why being on site has so much value for spatial. After all, we've been doing fine designing based on video interviews for years at this point. But what worked in the past won't work for spatial. And as a design professional, you're the one to convince your business of this. This is where you tell them that 60% of US workers aren't well served by screens, and that the industry as a whole is trending towards physical digital spaces. If the business is unable to commit resources to learning the right thing to build, they'll remain where they are while their competitors grow their user base and their mind share. But sometimes, even knowing all this, the business still won't budge. That doesn't mean you have to give up on observation-based methods entirely. Sometimes it's enough to have a participant do a remote interview on camera in their work environment, so you can see the layout and lighting and noise level. You can also ask them to capture work processes on video. That plus diary studies can be a good jumping off point to figure out whether there's enough potential to invest in further research in person. So while true fieldwork is always better, not being able to immediately go on site with a participant doesn't mean you're dead in the water. The next tool I want to talk about is the frameworks we use to analyze our user research. Generative research is messy. It gets even messier when you go from just paying attention to what people say to considering their environments. There are a number of different frameworks that have been published to help designers figure out what to pay attention to. One of the best known of these is AEIOU, which stands for Activities, Environments, Interactions, Objects, and Users. This framework comes from early design ethnographers way back in 1991. It's a great framework, and there's a lot of foresight in their decision to include categories for environments and objects at all. This framework has stood the test of time because it is very rich, but it's also missing things that might be considered important for product development, like goals and constraints. But if you look at more pragmatic frameworks like Jared Spool's from Putting Context into Context, you'll see that physical environment gets deprioritized to 1 item out of 8. The rest of them are largely informational, with the possible exception of tools. So this is going to be entirely inadequate if you're trying to design for, say, IoT. If you try to use off-the-shelf frameworks for discovering physical digital spaces, you'll find that they're either too broad or too narrowly focused on information flows rather than how workspaces are used. And that's not going to help you pay attention to the unique problems your spatial technology can solve for customers. You need to use a framework that is tailored to what your technology is actually capable of. And because spatial technologies are still so varied in terms of their capabilities and constraints, there's no one-size-fits-all framework. That means that you're going to have to allow your frameworks to be defined by the technology you're designing for. The easiest way to do this is to supplement an existing framework with more detailed subcategories when it comes to things like environment, objects, and activities. You've probably done this before, but now it needs to be formalized. So if you're designing for a sensor that detects body position, then you need to look for workflows where body position is an important variable. If you're designing for a robot that mimics human facial expressions, then you're looking for workflows with a social component. And if you're designing for a heads-up display, then you're looking for workflows where human workers need to refer to information and context. There's no one analysis framework that will get you to all 3 of these scenarios. Until there are more established tools and use cases, the only solution is to create it yourself. And the technology audit you did as part of your step 0 should help you do that. The third set of tools I'm going to talk about are our 2-dimensional intermediate design deliverables. So things like wireframes and click-throughs. The point of these tools is to explore and communicate and test a vision for the layout and interactions within an application. I probably don't have to explain why 2D wireframes may not be ideal for 3D spatial experiences. If you're in this talk, I expect you may have already looked into 3D prototyping tools in some form or other. So I'm not going to get deeply into the software. That's not my expertise. Instead, I'm going to talk about general approach. First, prototyping for spatial technologies, at least right now, is a lot more expensive than in 2D. I'm not talking about the cost of software, I'm talking about the time and expertise it takes to code and model spatial content, both virtual and physical. There are a lot of new skills for spatial design that most of us don't have yet, although you could if you'd caught wind of the trend early on with the Roomba and the Wii. Still, even today, many of the tools that exist to support this kind of work are either highly specialized, such as CAD software and game engines, or they're general purpose, but not that refined yet. So if you want to test out concepts for spatial efficiently without taking off a year to master expensive high-end software, you need to think lo-fi and embrace MVPs. MVPs get a bad rap because a lot of companies use them as an excuse to ship buggy software. But if you go back to the Lean Startup's original definition, what an MVP should be is a version of a new product which allows a team to collect the maximum amount of validated learning about customers with the least effort, which is exactly what we need. What this means for physical digital spaces is that you need to approach your designs not as fully fledged concepts, but as a series of hypotheses. You need to be thinking about what is the simplest way to test the value proposition before ever placing a voxel, which is a pixel in 3D. Once the value proposition is locked down, you can start to test how you'll approach task completion within the experience, and then progress to interactions. You cannot skip straight to high or even mid-level fidelity here. Not only is rework costly and time-consuming, but we're creating entirely new use cases and interactions. There are no best practices or pattern libraries to draw from. There will be more trial and error than on any 2D interface you've ever worked on. There will be problems you can't possibly anticipate because you were the first one doing this work, which is exactly why your company should be investing in research in the field instead of just phone interviews. So this is both the blessing and the curse of emerging technology. So when designing for physical digital spaces, especially over the next few years where we're still figuring all this stuff out, you're not a designer, you're a researcher first. Your primary goal is to come up with the fastest and cheapest way to test whether a concept is working for users. The other thing to think about as you're deciding how to prototype for physical digital spaces is that different technologies will require different kinds of prototypes. If you're prototyping for a display-oriented technology like augmented reality, then your prototypes are probably going to primarily focus on conveying how information looks in context. On the lo-fi end, you'll want to think about using tools like sticky notes or face shields with whiteboard markers or cardboard boxes or maybe Google Blocks. As you move to higher fidelity, you may want to use tools like Microsoft Maquette or Blender or even Unity or Unreal. But if you're designing for smart home or IoT or robots, then your prototypes are probably going to be less about the visuals and more about behaviors. You'll need to approach this from two ends, exploring both what the sensors and mechanics are capable of, as well as what kinds of use cases that enables. For the first case, that is understanding the technology's capabilities, you'll need to do what's called material exploration. If you want to learn more about this, Austin designer Vittorio Miliano has a great workshop, which I've linked to on my website. In terms of exploring use cases, your best low fidelity prototyping tool is probably Wizard of Oz testing, using human stand-ins for your technology. This is a technique we already use a lot in testing early stage voice interfaces, and it makes sense for IoT as well, because the quickest and cheapest sensors you have access to are the ones in your own body. As development progresses, you'll want to switch to testing the actual hardware, which is what higher fidelity prototyping looks like. All right, the last tool I want to talk about is iterative design testing, and specifically the environments where we do our testing. By now, you know that the spatial context is essential for how we design for physical digital spaces. This means that decontextualized research environments, such as labs and remote testing, will need to evolve. The best way to test designs for physical digital spaces is within their actual context of use. This means establishing relationships with potential customers who will test drive your designs while you're both right there together in person. You could theoretically do this remotely, but of course, video is going to miss a lot. But if that's not possible, or if you're too early stage to have a working prototype, then the next best thing is to test in an environment that's as similar as possible. This may mean modifying your lab space so that it resembles the workspaces of your customers. You'll need to think about things like lighting and noise level, surfaces, equipment, and tools. This is another place where your observational research will really come in handy. The closer you can get to the actual environment of your users, the better your designs will be. So that's 4 different ways you can update your design tools to enable better learning about your product's value within physical workflows. Now that we've talked about updating our assumptions and our tools, let's look at how this all comes together as a new end-to-end design process. So this is our process today. And this is what an evolved version of this looks like. So for any new product discovery, you'll start by auditing the technology's capabilities and checking your blind spots for users you may not be familiar with. Once you have a hypothesis about an audience your technology can serve, you'll research opportunities using observation-based methods. You'll analyze your findings using your own framework tailored to the capabilities of your technology. And you'll develop concepts and test your hypotheses iteratively as MVPs with low effort prototypes that progress in fidelity as you build confidence in your solution. And finally, once you have high enough fidelity prototypes, you'll test them with users in the actual real world spaces where they'll be used. Following this process ensures that you're utilizing your technology to its full potential and designing high value experiences that genuinely complement user needs in the physical spaces where they live and work. As we talk about evolving our processes, however, I do want to acknowledge that this should not be a new one-size-fits-all approach either. We'll need to continue to adapt our design processes as spatial technologies become more established, as new technologies emerge, and as new tools rise to support our changing practices. My hope is that we as a discipline will embrace the philosophy of user-centered design rather than venerating current practice, that will look critically at our existing processes and evolve them based on the needs of new users and new data-infused spaces. So to recap today, we talked about what a physical digital space is. We talked about the now outdated assumptions that go into flat screen design. We talked about how to evolve your processes and your tools, and we talked about how to evolve your processes and tools to design for physical digital spaces. As design professionals, it's our responsibility to recognize the biases that grew out of our origins 40 years ago. This is the time to do it. As computers evolve beyond flat screens, designers have an opportunity to lead in figuring out how to serve the 60% of the population we've long ignored. This is not only more inclusive, but working with and for new types of users is already unlocking use cases we couldn't have conceived of a few years ago. Spatial technology is not simply an offshoot of current computing, it's where the field as a whole is headed. The people and companies that get there first are going to be the ones to determine how our industry works for the next 40 years. So thanks so much for listening. You can find all of these slides along with the resources I mentioned up on my website at lewan.net/ADW2021. If you're a designer or a researcher who works in spatial, I'm always looking for folks to partner with. So feel free to get in touch via my email up here. If you're a product manager or developer or anyone else in spatial, I'd love to talk with you as well. To everyone, thanks so much. I'm afraid we don't have time for questions, as I mentioned earlier, but if you'll enter those questions in the chat, I believe Grayson will be copying those and sending those to me so I can update my website with answers.
Yeah, I'll leave the event up for the next couple minutes so you guys can put in any questions there, and then I'll get those over right after this event. But thank you everybody so much for joining us. Like I said at the beginning of this is the first day of Austin Design Week, and we have a ton of events all week. We have our opening event tonight, which is really exciting. That'll be in person and virtual. So check out our schedule. I'd love to see you the rest of this week. Thank you so much, guys.